I have a problem that I'm back into this now a little bit. I was doing congruential arithmetic, and now I'm more interested in this kind of stuff. I just kind of go back and forth. But anyway, we have a quadratic where we have two roots specified, and we're just supposed to evaluate based on this concrete example of a quadratic equation what one root raised to the 8th power plus the other root raised to the 8th power is. We're supposed to evaluate that without actually having to find A and B. Now, something that comes in quite handy right here is just to look at what happens when you expand this polynomial. A and B are specified as roots, so that means we have this factorization here. And so when you expand this out, you end up with negative the sum of the roots plus positive the product of the roots, all right? And so from there, let me get my marker working here. Now, there's an understood 1 right here in front of x, right? There's a coefficient of 1 right there. And so we really equate 1 equal to minus a plus b, which means a plus b is equal to minus 1. Okay, again, 1 is the coefficient of the x term right here. 1 is the coefficient of the x term. We have to equate it to negative a plus b because that's the way the factorization works out when you expand. And so we know that the sum of the roots is negative 1. All right, we don't know what the roots are, but we know that their sum is negative 1 and that their product is 10, okay? Now, the rest of this, we're just using the well-known a plus b quantity squared. A plus b quantity squared is equal to a squared plus b squared plus 2ab, but it's more convenient to write it this way. And the reason being is we know what a plus b is, right? We know what a plus b is. It's equal to negative 1. And we know what ab is. It's 10. Now, we started here, but the same kind of pattern prevails all the way up to a to the 8th plus b to the 8th. All right, and so this is just kind of some jury arithmetic right here. Again, a plus b is given, ab is given. If you substitute into the appropriate spots right here, you get a squared plus b squared is equal to minus 19. And that means if you square one of the roots and then add that to the square of the other root, you get minus 19. So we could have asked that question up here. We could have asked what is a squared plus b squared. We didn't. We asked what is a to the 8th plus b to the 8th. But this ends up being recursive. Notice that we need a squared plus b squared right here when we're doing a to the 4th plus b to the 4th. Just like we needed a plus b here, we need the output of this expression up here, down here. And we know that that's minus 19, so it's recursive in that sense. And when you do the arithmetic right here, you get minus 161. And again, had we asked the question, what is a to the 4th plus b to the 4th, the answer would be minus 161. Now that's kind of weird, isn't it? Because you're talking for real values, that's not passable. We are talking about complex solutions here. If you take a look, the discriminant of the original expression is negative 39. So we are talking about complex or imaginary solutions. So you can square, like, for example, I squared is a negative 1, right? And so you might think this is crazy that a squared plus b squared is a negative number, and it couldn't be if we're dealing with real value numbers, but the roots are complex in this case, and you can tell by looking at the discriminant. And so we carry on in a similar fashion. We know what a to the 4th plus b to the 4th is, and so we're just going to substitute it right here, and we'll have 10 to the 4th right there. And so this is our final answer. The final answer is 5921. And folks, if you didn't already know, this is basically the same thing as just what they call Vieta's formulas. It's Vieta's for the it's Vieta's formulas for just the quadratic case. That's VIETAS, Vieta's formulas. That's supposed to be an E right there. Okay, Vieta's. This is Vieta's, and I never memorize that, but you can. It's easy to expand it out in the quadratic case. Hope you guys enjoyed.